To navigate in the level, we want the user to bring up a navigation menu showing a live view of the map where they can select a point of interest to teleport to. The top mode in the navigation menu makes it easier for the user to understand the space as they choose a new location, while the preview mode provides them a point of view of the location before they teleport there. We'll start building our navigation map by creating a scene capture component to grab a live view of the level from above and save the image to a render target that we'll use later as the background of the map. Let's begin by going to our Nav VR folder and open the Gameplay folder. Right-click and create a new folder named Actors. Create a new blueprint class of type Actor and name it BP_scene capture and open it. First thing we need to add is the scene capture component 2D itself. This component will capture anything live in the scene and will use its feed to draw onto a texture that we can use in our widget. The way we'll achieve that is by using a render target. Create a new render target and save it to a new textures folder within NavVR. Name it RT for render target _ scene capture and save and compile. We need to change the capture source so that we'll be able to see it on our monitors and in our HMD. Set it to scene color HDR in RGB and the scene depth in A. Let's make sure this combination is working for what we need. Compile again and drag an instance into our scene. Navigate to the newly created textures folder and look at the thumbnail of RT scene capture. You can see that it is being drawn on by the feed of the camera. And if we zoom into it, you can see that it is a live view. Temporarily, I want to also add a camera component to the blueprint so I can quickly see what it will see. Let's place this blueprint where our top mode will be using it. I'm going to set the Y rotation to -90 and drag the blueprint way above the ceiling. As I drag it up, an obvious barrier comes into view. The ceiling is making it difficult to see inside the room, which makes sense. So we need to set up a way that tells the scene capture component only to capture actors who have pivot points located under a certain height. In our BP scene capture, make a new variable and name it height. Set the type to float and place it in the category scene capture vertical bar parameters. Create a new function called getAllLevelActors. Drag out and search for getAllActors of class. Remember back to our course on hierarchy. If I get all classes of type actor, I will have a reference to everything in the scene that is derived from that class. This includes all the static meshes, the blueprints, the lights, all of it. So here's another example of communication in blueprints with objects that aren't even themselves blueprints. Use this technique lightly. Doing a global search for such a low-level class is not an easy nor quick task. So I only want to do this one time at the beginning of the game and promote it to a variable named AllLevelActors. We will be testing this logic in the construction script shortly. So I want to make sure I clear the array before setting it again, just to be certain that there is no issues with validity. Place this function into the category Scene vertical bar data collection. Create another new function and name it build show only list. Place the AllLevelActors variable into the scene vertical bar data category. Duplicate the AllLevelActors variable and name it show only list. Get a reference to show only list and again start by clearing it. Okay. Get our AllLevelActors variable and connect it to a for each loop. We are going to go through each reference in this array, first checking if it's valid, and then getting the location of the actor. If the z location, or the height, is less than or equal to our height variable, we'll add it to the list. If it is above that variable, it won't be added to the list and will be hidden to the camera. Grab the scene capture component and drag it into this function. Then drag off that reference to set the show only list and plug it into completed. Hook up the show only list and comment that this will set show only and hide everything else in scene. Comment on the loop body that this will select show only actors by pivot's Z location. And compile this. Make the height variable instance editable so we can change the value in the scene. Open the construction script. Drag build show only list to the data collection category. Okay, place in the function get all level actors and connect it to the construction script. And pull in the build show only list as well. Compile. The last setting is to switch the primitive render mode to use show only list. Back in the content browser, search for your RT_scene capture. What you are seeing is the array of actors who have Z location at or below 0.0. As I increase the slider, we'll see more and more actors. Around 250 is showing what our top view should see minus the balcony. Before we move on, set the size X and size Y to 1080 by 1080. The higher that resolution is, the more processing power it will take to build that image, and it will need to be rebuilt every frame. We want it high res, but nothing more than what is needed. Back to this height variable. If I set it back to 0 and increase it again now that the resolution is higher, you can see what will become our ground floor area. This way, we are free to place travel locations underneath the balcony and not worry that they won't be seen. For our balcony, we'll use the value 500. At that point, we will hide the ground floor locations and display our balcony points. So this is the texture we will use as the background for our map. We've created the mechanism for storing a live image of our level for the navigation map. Next, we'll create the navigation map widget and use this scene capture's render target as the main visual.